Hi class, welcome to lesson 5 on density. In this lesson, you will learn how to determine the volume of a substance and to calculate density, mass, or volume of a substance in a word problem. Let's get started. So, density is a relationship between both mass and volume. So, mass is the measure of the amount of matter that something contains. And matter is made up of atoms. So mass is directly related to the number and size of atoms inside a substance. So here you could see in this picture of these particle diagrams that we would expect the box on the left to be more massive because its atoms are larger, and right now we will imply heavier than the atoms on the box on the right. Now, volume is the amount of space something takes up. So here you can see two different figures. A has a smaller volume than B because B takes up more space than A. From elementary math, we know that taking the volume of a regular solid can be done by multiplying length times width times height. Now, if we're dealing with liquids or gases, we can measure volume in a graduated cylinder. It's important that when we measure graduated cylinders, we always examine them at eye level and we read from the bottom of the curved surface called the meniscus. Now, in this graduated cylinder, notice that the ones place is provided. So our estimate must include the tenths place. Another way to find the volume of a substance is via water displacement. In order to use water displacement, you'll take an object and first you'll fill the graduated cylinder with water and measure the initial volume. Then you will add your object and the level of the water will rise. Then you'll measure your new volume. The difference in the volume is the volume of the object. So these two objects here have a total volume of 2 milliliters. So by now, you should be able to determine the volume of a substance. Now, density is the relationship between both mass and volume. Density is a relationship between both mass and volume. What you can see is that mass on the left increases when we increase the number of particles. Volume increases on the right when we increase the amount of space. Officially, density is described as the ratio of mass to volume in an object. And here you'll see that on the very back of your reference table T, you are given the density equation. So for this lesson, for your notes, it is important that you write down this equation, but you do not need to memorize it, as you will always be provided a reference table for tests, quizzes, and of course, the Regents exam. So you can see in box A, because I have more particles in the same amount of space, I'm going to have a greater density. So now let's take a minute to try some practice problems. Before we begin, make sure that you have a Regents chemistry reference table and your scientific calculator. Let's get started. Okay, let's try a few practice problems together. When we do these problems, you should have your Regents chemistry reference table and your non-graphing calculator. In this question, it asks us to find density. So we're going to start by writing the formula for density. After you identify the correct formula, you should substitute your known values here. So in this case, we know we have 60 grams, and we know we have 2 cubic centimeters. By the way, a cubic centimeter, 1 cubic centimeter, which in the medical field is called a cc. So 1 cc is the same as 1 milliliter. These are all the same value. So we can see the volume in any of these units for calculating density. So here we have this, and we know that this is what density equals. So we're going to put this value in our calculator. And we get an answer of 30 grams per cubic centimeter. Since the number 2 only has one significant digit, our answer of 30 should only have one significant digit, so we'll write it without a decimal point at the end. So when we're solving questions in chemistry, we always want to begin with the formula from the reference table. You must show a substitution, and you do not have to show algebra, then you show your final result. Remember that all measurements should have a number and a unit. Let's try this example. Here we are given a volume of 825.0 cubic centimeters and a density of 13.60 grams per centimeter, and we were asked to find the mass. So what we're going to do is we're going to start with the density equation from our reference table. From here, we're going to substitute. So the volume is 825.0 cubic centimeters. If writing the units inside of the math confuses you, you can just write your math without the units like this. They mean the same thing, so it doesn't matter. And then we also know the density is 13.60. And we're looking for the mass, so we're going to call that m, and so we need to solve for m. Here I have a fraction on one side and a whole number on another. This happens a lot in chemistry. The easiest way to solve this is to put this over 1. So whether you write units in or not, that's okay, but we're still going to put this over 1 to turn it into a fraction so that it's easy to cross multiply. So when we cross multiply and we place this in our calculator, we put this in our calculator, we find that our mass equals 11,220 grams. Remember, no commas in chemistry. Let's do one more problem together. Again, you always should begin by writing down the equation, and then you should show a correct substitution. And from here, we can solve. In this question, we're looking for the volume of aluminum. So what I'm going to do is I'm going to start with a density equation and plug in the values that I know. So here I can see that volume of the sample is 251.
So what I'm going to do here is I'm going to plug in what I know. I see that the volume of the sample is 251 cubic centimeters. Again, if writing in the volumes makes this difficult for you, you can write this in with just the number, like this. But we have a problem. Here, we know that we're looking for the mass of the sample, but we're not given density. This is where a reference table comes into play. Let me show you.
So you can see here, we can look for element number 13. You can see the density of aluminum.
So if we take the value from the reference table, the density of aluminum is 2.70 grams per cubic centimeter, or simply 2.70, whichever way you prefer. And again, we have a fraction on one side and a whole number on the other. Turn this into a fraction so that you can easily cross multiply. Once we cross multiply, we'll find that our mass is equal to 678 grams.
So by now, you should be able to calculate density, mass, and volume. This concludes the end of lesson number 5. Make sure you've taken good notes. You complete your homework on Google Classroom, and I'll see you soon. Also, don't forget to put your calculator and your reference table back in your bag so that you don't lose class participation points for being unprepared. See you soon.